I am Catubig and I'm going to discuss on how to simplify square roots.
Simplifying square roots. In mathematics, a square root of a number a is a number y such that y squared is equals to a. In other words, a number y whose square, the result of multiplying the number by itself, or y times y, is a.
So first, we must know the perfect squares of a number.
2 squared is equals to 4. So the square root of 4 is equals to 2. 3 squared is equals to 9. So the square root of 9 is equals to 3. 4 squared is equals to 16. 5 squared is equals to 25. 6 squared is equals to 36. 7 squared is equals to 49. 8 squared is equals to 64. 9 squared is equals to 81. 10 squared is equals to 100. And so on and so forth.
Oh. For example, square root of 36. Now, consider the factors of 36. So we have 9 and 4, 6 and 6, 12 and 3, and 36 and 1. With these factors, we will specifically consider those factors which has the perfect squares. So we have 9 and 4 and 36 and 1. So we will use the 9 and 4 factors. So square root of 36 is equals to square root of 9 times square root of 4. We can rewrite this as square root of 9 times square root of 4. As we have learned a while ago about the perfect squares of a number, so square root of 9 is equals to 3 and square root of 4 is equals to 2. Therefore, square root of 36 is equals to 6. We can also use the factors 36 and 1. So square root of 36 is equals to square root of 36 times 1. We can factor 36 as 6 squared. So we have square root of 6 squared. We can simply cancel this out. So the square root of 36 is equals to 6. We can use different factors in simplifying square roots but come up with the same answer. Another example, square root of 50. We will find a factor of 50 which has a perfect square. So we can use 25 and 2. Since 25 is a perfect square and we can simplify it, so we have 5 square root of 2. Since 2 is not a perfect square, or we cannot factor it anymore with a perfect square, remain this as it is. So we have square root of 50 is equals to 5 square root of 2. There is another way in simplifying square roots. For example, we have 300, the square root of 360. We can use the prime factorization. So 360 we will now find the factors of 360. So we have 36 and 10. Since 36 and 10 are still composite, we can still factor this out. So we have 36, 6 times 6. And the 6 has the factors of 2 times 3. The same here, 2 and 3. Since 2 and 3 are already prime, we can now move to the factors of 10. So we have 5 and 2. 5 and 2 are already prime also, so we're done. So we can write this as the square root of 360 is equals to the square root of, so we have 2 cubed since there are 2, there are 3 2's, so 2 cubed times there are 2 3's, so we have 3 squared times this, the 5. So now we can rewrite this as the square root of 2 squared. We write this to cancel out easier. So 2 squared times 2, since 2 squared times this is equals to 2 cubed times 3 squared times 5 equals, so we can now cancel out the exponent of 2, which is 2, because this is square root, and we can also cancel this. So since 2 and 3 were already simplified, we can write this as 2 times 3, then the square root of the remaining one, 2 times 5. So now 2 times 3 is equals to 6. Then the square root of 2 times 5 is equals to 10. So we have the square root of 360 is equals to 6, the square root of 10.
If the simplified root is a whole number, then the square root of a number is perfect square. For example, the square root of 121 is equals 11. 121 is a perfect square, so its simplified root is a whole number. The square root of 64 is equals to 8. The square root of 625 is equals to 25. Otherwise, if it is not, then the square root of a number is non-perfect. For example, the square root of 48 is equals to 4, the square root of 3. The square root of 63 is equals to 3, the square root of 7. And the square root of 384 is equals to 8, the square root of 6.
That would be all, and thank you for watching.